Thank you so much for coming. I wanted to thank Seed Studio and Chaiwa Hackerspace for inviting me to speak and for Maker Faire for bringing everyone together. My name is Mike Szczys. I'm managing editor of a website called Hackaday.com. And I'm actually celebrating this year 10 years of being Linux only. And open source software has been a big thing in my life. And lately, as open source hardware has become a thing, I've really studied it a lot and gone around and talked to a lot of people about it. I'm excited about seeing it succeed. And I'm going to talk about a few of the things that I think are good and a few of the things that could be improved and a few of the things that are troublesome today. But first, I always like to talk about what Hackaday is. And so Hackaday is kind of a multi-part group of people that are really excited about hardware. I like to call it a global virtual hackerspace. So people that like to talk about hardware, like to talk about hacking software, maybe their husband or wife or next door neighbor are tired of having them come over and try to tell them about this stuff and want to find other people that are just excited as they are. So for 10 years now, we've been writing articles on people that are doing this stuff, which gives them a platform to go and talk about this in comments and have lively debates and collaborate on projects. But that's kind of a one-way street. People can only really talk about the things that we're publishing. And so about 18 months ago, we started Hackaday.io, which is our community. It's a platform where people can go and post about their projects, and they can start their own conversations. They can collaborate as a team on things. And it's been incredibly successful. We now have over 72,000 registered users, and they're doing a lot together. I'll talk about that a little bit later. And we also started an engineering initiative last year called the Hackaday Prize, which encourages people to document things that they're working on and to work on things that are maybe a little bit more important to the common good than they have been in the past. But let's talk a little bit about what we believe in. So we believe in the free and open sharing of information and ideas. A lot of times, especially when you're talking about hardware security or computer security, people are worried about talking about that and getting it out there and having someone maybe take it and use it in a way that they shouldn't. But I think talking about it is important. And one of the examples that I like to use is this little device right here. It works with the Tektronix oscilloscope. So Tektronix makes really high-end oscilloscopes that you can unlock extra features for if you buy a little dongle. And someone found out that on that dongle was just an EEPROM with a word on it, a plain text word that you can find on Tektronix's website. And if you put that in the oscilloscope, it unlocks the $500 feature that you're supposed to buy for it. And we wrote a post about this, and Tektronix immediately was not happy about this. But the thing is, this is not good hardware security. And if you just try and hide a story like that, what ends up happening is the next generation to come up and build hardware security makes the exact mistake over again. It's not a good design. And so when we talk about things, it prevents us from actually doing the same thing over and over again. And a lot of the times it doesn't really matter. You know, if your child's toy runs out of battery way sooner than it should be, it's not a big deal. But if all the passwords for your accounting online get stolen because there was a flaw in the software, that's something that we don't want to keep putting in new things. So talking about it as engineers makes a difference and really helps us find the answers to those problems. And the other thing is talking about that, someone might not have the solution right now, but they might have a partway solution. And if they talk about that partway solution, the next person that can come along looks at it and says, I know how to improve that. And we get an iterative effect on it that can be the solution to basically all of our problems. So people like to talk about the definition of open software and open hardware. And I think this is difficult. I mean, it's only been about 10 years since the open software definition was kind of agreed upon. But in general, I look at these definitions and I think the important thing about them is that when you make something open, that you talk about what it is about that that's open. Can it be reused? Can it be reused for commercial use? If someone reuses something of yours, hardware or software, can they take it then? Are they then obligated to share their changes with the next person? I don't know that you need an actual answer for this as much as you actually just need to talk about this. And I think with open hardware, that definition, if you look up open hardware, open software, you'll see that just about as long as we've been talking about open software in an organized way, we've been talking about open hardware. But I think there's less consensus on what open hardware is and how it should work. If we look at how pervasive hardware is right now, open software is right now, we see it everywhere, and especially on the internet. So we get the Penguin here is Linux. Linux is running on a huge amount of hardware that's running the internet right now and really has facilitated a lot of that. Also built on the Linux kernel is Android, and that's an interesting thing to look at because some of it is open, some of it is closed. But in general, the thing that's encouraged is go take this, use it on your own hardware, push back any changes that you can so that everyone benefits from it. And we start seeing hardware being pulled along with open software in a large way because of Android. And then I always like to talk about the Apache HTTP server because serving up web pages, that became a really easy way to do it. It was kind of transformative when it came out, and the foundation has gone along to do a lot of other things. So look up Apache if you get some time. The other thing is by nature, for software, we need to be open. You need to be able to go and look at how software is working, especially because you don't want to have bugs in the software that's being used to compile your software. You don't know if the bugs are coming in from the compiler or if the bugs are coming in from something that you wrote. And so when you go and start looking at programming languages, a ton of them are open, and at this point, it's almost just agreed upon that software standards are going to be open so that you can go and look at them, build upon them reliably. You don't have to worry that, you know, if a company goes out of business, then the compiler is not going to be available anymore and you're going to have to completely change your product. And I don't think that there is really anything in hardware that kind of matches this kind of flavor of openness. But we have seen some very promising things about open hardware, and I always think you have to talk about Arduino if you're going to talk about open hardware. The biggest thing that I think Arduino did is they set a standard, and they said, this is something that you can build around, this is something that you can have a community to get excited about. You know, there are some things like we want to link back to the original Arduino, but they also encourage and allow people to go out and form derivatives. And what we have with those derivatives is the ability to upgrade and get the better hardware without making the entire community and the entire set of early adopters move with you. And my favorite example of this is the Teensy 3.1. So instead of, if we look at the original Arduino, this is running an Atmel 8-bit microcontroller. And for the vast majority of people using Arduino, this is plenty powerful chip for them. But when you have people that really start pushing the boundaries, we move up. This is an ARM controller. And anyone that's done embedded development knows that ARM is a lot more difficult to kind of get the hang of. There's a bigger learning curve at the beginning of it than an 8-bit legacy microcontroller. But the flip side of that is that you get a lot more power. So what the Arduino community has done is it made it possible for people to utilize this hardware in a much higher way, and they still feel like they're interacting through the Arduino IDE, which is standardized across different hardware in the same way. The other thing is because the Arduino makes all of their, the bootloader and the code that's running on it in the IDE open source, you can build Arduino on your own hardware, and we actually even see community-driven things. So like the ESP8266 is a little Wi-Fi dongle that's been very popular lately. A group of people, because of their own interest, just went out and adapted the Arduino IDE to run on that hardware. So we see the ability of open to, kind of extend the use of hardware that's already existing, and I think everyone, including manufacturers, benefits from that. Another place that you can look at open is in development boards. So this is a very narrow Texas Instruments development board. This is the TI Launchpad, and the image got squeezed. I'm sorry about that. But all three of these are development boards that are made for engineers to learn how to use new hardware. And so this is a Texas Instruments ARM chip, Atmel ARM chip, and a Freescale ARM chip on these boards. And the thing is, they publish their schematics, so in a way that hardware is open. And they also publish code, and they give you development environments and really get you going with examples and sharing examples. The one place that we don't see open on a board like this is the programmer that's actually pushing code onto the chip. There's usually programmers and debuggers, and on these, there's a smaller chip to the top half of the board. We see the big chip in the middle. Smaller chip to the top half of the board is what makes it possible to get code from your computer onto these development boards. And that part's not open. You can't, it's a blob. You can't get the source code for that. But that's okay. I applaud companies for going out and publishing something and just trying out open. I think open is not an all or nothing event. So looking into a little bit more like fully open hardware, trying to find where are examples that people have actually adopted and embraced open hardware completely, and how is that being spread? So this is the laser saw project. I think laser cutters are really hot right now, but the knowledge that you need to actually build a very, very high quality laser had been kind of absent. This project actually, for about $10,000 in parts, allows you to build a laser cutter that would be more of a $40,000 to $50,000 thing. The big problem here is the skill that you need to complete this project successfully is very high level. So you end up seeing this used by collectives. So makerspaces and hackerspaces bring together all the different people with the skills that they need in order to build this. So really, it's hard to get wide adoption of this because you already have to have such a high knowledge level. But a good example of wide adoption is the multi-copter project, or the multi-Wii project. And this started off with the Nintendo Wii motion controller, which has a really good IMU, or inertial measuring unit in it, and was sold through Nintendo, so everybody could go and buy it. And people started building quadcopters. This is actually a tricopter, it's one of the first one. And this is the sensor that allows the machine to balance itself so that it'll stay flying even though your thumbs are a little twitchy. And what ended up happening is, after a while, they pushed the hardware so far, just as far as they could. They also have an open software component that runs it. And they said, look, we need more, we need better, there's better chips out here. And so the community got together and started designing their own hardware and making that hardware open source. And it's to the point now where this board on the right is actually for sale through Hobby King, which is a pretty well-known RC vehicle site. And so you have a ton of people that are buying this who know nothing about hardware, but they're benefiting from this open hardware. And the community also invites you to come in and build your own attachments for it, or take your own spin on it, switch out the hardware, and move everything forward a little bit. So I talked about it a little bit before. To get into open hardware, it's really easy. Basically, you need to create something. And when you create it, when you're starting to release and starting to talk about it, you should also start thinking about licensing. Because one of the ways that we can be good neighbors in open source and open hardware is by telling people that you are allowed to use this, right? That's one of the biggest things, is if you just put something out there, people don't know. Like, can I go and use this in my project? What do I need to do? Do I need to say your name? Do I need to track you down? Does everyone that wants to use something have to email you and get your explicit permission? One of the ways you can tell people that is by choosing a license. And there's a lot of different licenses. I really like using the MIT license. You can Google open source or open hardware licenses and find a lot of them on Wikipedia. But I think the point is, if you don't explicitly say that you're sharing it, you're not sharing it. Because someone that's trying to be a good neighbor in the community is going to feel like they can't take it and use it. And that kind of puts up a barrier for one of the biggest benefits, which is a multiplier of talent within open source. And there's tons of platforms available for sharing things as well. So like, I think most people are familiar with GitHub. Finding a way that you can, GitHub allows people to attach projects together by forking them, and then you can see whose project came from whose. Finding a platform that allows you to kind of give credit and explore and share different things, again, removes the barriers to adoption. Yeah, okay, so one of the things I like to look at is how far we are with open software, and is open hardware going to catch up? So I do think open software is about 10 years ahead of where open hardware is. So with open source software, I think at this point, everyone that uses a computer is expected to be able to code. And I mean, that's a pretty bold statement, but if you think about it, if you can't write a formula for a spreadsheet, you're probably not going to be doing a job that uses a computer. And at a very, narrow level, that is coding. And especially people that are working a lot with computers are just expected to be able to kind of figure things out. And I think that comes from having millions of examples available that you can actually go and look. So even if you don't know a particular language, if you know something about coding, you can go and Google that language, you can find examples and discussions that are already out there and learn from it. One of the things that I'm really excited about is with open hardware coming up, if you have an 8-year-old that's blinking LEDs with an Arduino, and then they move on to a Raspberry Pi and start working with embedded Linux, in 30 years when that 8 or 18-year-old is going to be running an engineering department, what is the hardware going to look like coming out of that? And I think that's one of the ways that open hardware can grow, is these early adoption and learning, getting kids involved in being excited about engineering and being excited about math through this is going to make us have a bright future. Where are we at here? It helps us stop solving the same problems. It provides an education. So my electronics education is pretty much all self-taught. I actually have music degrees, but on the same time, I think I'm a fairly competent embedded developer. I spin my own circuit boards. I look at other people's designs and understand them. And this is all knowledge that's come through from people sharing their own experiences. The other thing is I always talk about it being an idea engine. So you know, people are worried like, okay, if I put my project up on Hackaday.io, I'm worried that someone's going to steal it. And the thing is, 99.9% of the time, no one's ever going to build your project. That's just the way it is. Like, most of the time, 99.9% of the time, you're not going to build your project again either. But the thing is, being able to look at that, someone says, oh, that's a cool idea. I could use that idea in my project. And then that ends up being this chain of ideas or this network of ideas that really can be explosive. And I do always like to talk about selfishness, because people are selfish. I'm a selfish person. So I have many examples in my life where I'm working on something that's hard, and I'm like, oh, I know I solved this before. I know I wrote my own piece of code that fixed this. And then I go and I'm like, did I put that on GitHub? I hope I put that on GitHub. We're going and trying to find it. And so we really look at documenting for yourself. It also goes out, even if no one looks at it, chances are someone at some point is going to see that code. And it's there for you to use, but they can also benefit from it. It grows your skills, so just being involved in the open hardware community, people are happy to mentor and people are happy to help with it. So it's a selfish thing. You can go and get access to really high-level engineers who are willing to take their time to teach you something. I did a lot of work early on in, not work, I did a lot of play early on avrfreaks.net, which is the Atmel forums, and learned a ton about reading data sheets and using peripherals and some of the really hard parts of getting into embedded, just because I was able to go and ask questions on forums. And the other thing is, if you put your own hardware out there and kind of build a big resume of things, you could score a sweet job out of it, because you're going to be able to go and say, look, here's the work I've done. People are often worried about that because they're like, well, look, what if the work's not very good? And I said, look, it's the internet. It's not like you put it out there and you can never go back and change it. So as your skills get better, you can go and actually produce these things. I also always tell people, if you're looking for a job these days, you should be able to write at a high level about what you're working on. I think talented people are expected to be able to talk about what they're doing. This is a great way to practice it. Go document it. Teach someone else how to do it. Employers need people that can do that, and you're proving to them that you can. There are some problems with open in general, and so there we go. So one of the big ones is trust. So if somebody comes to my project and sees that I used a footprint, and then takes that footprint and puts it in their own design, and then goes and spins a board and comes back, and it turns out that I have it upside down and the pins don't work, and now they have this board that is just a paperweight. That's a really tough thing. Some people are starting to solve that, so I think so businesses, seed studios, Adafruit, SparkFun are building open source libraries, and the thing is they're kind of building credit for engineering. So if you can go and look and say, this thing works, this library works, I can look at the code and know that the library's good, then you feel like their hardware's good too, and you're more likely to go buy hardware from there. You consider a reputable source. And that's a good business model. Another thing that I talked about before was that 1% open is better than 0% open. So one of the problems is legacy. People say that this is proprietary information. If we let it out there, our competitors are going to get it. They're going to take it and run with it. And your answer shouldn't be, hey, everything has to be open, otherwise people are going to hate us. Your answer should be, look, we'd like to build up a community around this. Why don't we make the user side of this, some of the scripting on this, open and really document it well and get people excited about it. And if you get that kind of adoption, you kind of lock in your customer base. So, Hackaday doesn't really make anything, but we are trying to push engineering forward and push bigger adoption into open hardware. And so, like I said before, we started Hackaday.io, which is our community platform, about 18 months ago, like February of 2014. And it's really up there for people to do anything they want. I'd love it if you put your hardware projects up there. You want to put software projects? Great. Want to talk about your favorite movies? Wonderful. What I think it is finding people, connecting with people, and talking about the things that you want to talk about. Again, that becomes the idea machine, and it becomes the sharing of knowledge. And then the other thing is the Hackaday Prize. And the Hackaday Prize is, this is the second year of running it. This year we're asking people to build something that solves a problem faced by a lot of people, but to make that open as well. So the level of openness, the level that you've shared with it is one of the deciding factors. We're giving the winner a trip into space or $196,883. And the entire prize pool is like $500,000, but it's a way that we can get literally hundreds and hundreds of people. We had 860 entries last year, and this year's shaping up to be way bigger than that. We had amazing examples of the top 5 winners. So we have a network of satellite ground stations on the upper left of those grand prize winners. So you'd build a satellite ground station in your backyard. People would do that all over the world, and then you can share the data coming down from satellites through a network that they also built on top of it. The Chip Whisperer is like hardware security, which previously was tens of thousands of dollars. Now this is just thousands. Portable SDR takes software-defined radio, which traditionally has needed a computer to be involved with it, and removes the computer completely. And this can be huge for like disaster environments, or it could be used for communication when backwoods backpacking or going out in the ocean. The Open Science Tricorder is kind of making science fiction a reality. So if you've seen Star Trek and seen tricorders, this is actually for real. You can hold it in your hand. I always like to say school children learning about the weather can take this and learn about barometric pressure and temperature and see how the weather changes based on those measurements. And it's cool. They're excited about it because they actually have a dedicated piece of tech to work on. And the Ramen Pi is a Ramen spectrometer, which is a laboratory-grade measuring device, again, costing tens of thousands of dollars. If you think about a small university, they might have the budget for a scanning electron microscope or a Ramen spectrometer, but not both. If we find a way to make tools that are pretty good and affordable, what you might be able to do is have both things and give the students the ability to use the tools, even if they're not quite industrial grade, is better than not having it at all. So this year, like I said, we're doing the Hackaday Prize again. I encourage you to go check it out, check out the entries that everyone has been doing. Enter your own, talk to people about it. And in general, I like to say when I close these, I don't really care where you put your project or how you document it. But I think far too many great ideas die because people either don't want to take the time or don't know how to talk about them and share them. And so find a way, even kind of let go of your pride and don't say, my write-up's not going to be good enough. Your writing gets better as you try it out. Your documentation gets better as you try it out. And if you actually put something out there, you'll see the response is always overwhelmingly positive and overwhelmingly supportive. So I think the future of engineering is open hardware, and please give it a try. Thank you.